Okay, here I got a system of linear equations. This is how you'll see them written. And I got one equation here, y equals x plus 1. That's written in slope-intercept form, which we went over. And then 3x plus y equals negative 3. That is in standard form. And remember, the whole point of systems of linear equations is we want to figure out where do both of these lines, where do they intersect if we were to graph them. And so you can graph these by hand or putting them into Desmos and you'll get your answer. But if you don't have that available to you, like you're taking a test or whatever, you want to be able to use substitution, use some algebra to figure out what that point of intersection between the two lines is. So we're going to use substitution. And again, I have y is equal to x plus 1. And I'll say that again, y is equal to x plus 1. And then I have 3x plus y equals negative 3. But just listen to what I just said. I said y is equal to x plus 1. Well, I have a y right here. So I'm going to substitute what I know y to be into that instance of y that I have in the in that blue equation right there. So I have 3x plus y equals negative 3. And I just said y is equal to x plus 1. So I'm going to replace that y right there of 3x plus x plus 1 equals negative 3. Now I have a equation here with one variable. I just need to combine my like terms. I can solve for x, and then we'll go from there. So 3x plus x, that's going to be 4x. And then I have the plus 1 equals negative 3. Just solve for x. So I'll subtract 1 from both sides. That's going to cancel out. I'll have 4x is equal to negative 4. Divide both sides by 4. And I'll have x is equal to negative 1. So we're halfway there. We have the x-coordinate of the point where these two lines intersect. So I know my point is going to be negative 1 comma something. How do we get the y value? Super easy. So we have our x value, and we know that both of these lines, they're going to go through this point that they intersect at. They're both going to go through it. So I can take the x value I got here, and I can substitute it into either one of these two equations and solve for y. So pick whichever one's easier. This one looks a lot easier, so we'll go with that one. So we'll have y is equal to x plus 1. But instead of x, I'm going to plug in negative 1. So we'll have y is equal to negative 1 plus 1, or y is equal to 0. So there is our y-coordinate. So the solution to this system of linear equations, or the point where these two lines intersect, is negative 1, 0. And here it is in Desmos, just in case you don't believe it. There it is. Negative 1, 0 is our solution. Here's another one. I got y is equal to negative 5x, and y plus 3x is equal to negative 2. So this first equation tells me what y is equal to, so I'm going to substitute that into the y in the blue equation. So I'll have y is equal to, or I should say, y plus 3x equals negative 2. Just start there. And then y is equal to negative 5x. So instead of y, I'm going to write negative 5x. And then plus 3x equals negative 2. And solve for x. This is going to give us the x-coordinate for the point where these two lines intersect. So negative 5x plus 3, that's going to be negative 2x equals negative 2. Divide both sides by negative 2. That's going to cancel, and I'll get x is equal to 1. So there is the x-coordinate. For the y-coordinate, again, just take your x value and plug it into either equation. Usually you go with the one that looks the easiest, like this one, but it doesn't matter. You will get the same answer as long as you do the math right. So we'll have y is equal to negative 5x. Instead of x, I'm going to put in that negative 1 there. So we'll have y is equal to negative 5 times 1. Negative 5 times 1 is just negative 5, so y is equal to negative 5. And the solution to this linear system of equations is going to be 1 comma negative 5. Throw it into Desmos or graph it by hand, and you will see that you have that same solution right there, 1, -5. All right, here I got y is equal to 5x minus 3 and y is equal to 3x minus 1. So both of these are equal to y. If both of these are equal to y, they're equal to the same thing, then they're equal to each other. So we can just set them equal to each other. So I can put 5x minus 3 is equal to 3x minus 1. Remember that this is y, right? Y is equal to 5x minus 3, and so is that. Y is equal to 3x minus 1. So we're just setting them equal to each other, and then now we solve for x. So I'm going to get x to one side. I'll subtract 3x from both sides. That's going to cancel out. So we'll have 2x minus 3 is equal to -1. I'll add 3 to both sides. That cancels. We'll have 2x is equal to 2. Divide both sides by 2. That cancels out. So we'll have x is equal to 1. And then for y, again, just take that and plug it into either one of those two equations. Doesn't matter which one. We'll go with the blue one there. So we'll go y is equal to 3x minus 1. I'll replace that x with the 1 that I got previously. So y is equal to 3 times 1 minus 1. Y is equal to 3 times 1 is just 3. Minus 1, y is equal to 2. So that means the solution, or the point that these two lines intersect at, is going to be at 1, 2. Again, here it is shown in the graph to prove that what we're doing will get you the same answer as graphing. Okay, this one is really similar to the last one. There's just this negative sign here, so just be careful with that. But other than that, everything will work the exact same way with the problem we just did. Y is equal to 4x minus 3. Negative y is equal to x plus 3. So I'm going to roll with that one first because I know that y is equal to 4x plus 3. So I'll start with that blue one. I'm going to write that out. Negative y is equal to x plus 3. But I know that y is equal to 4x minus 3. So I'm going to replace that y with 4x minus 3. So 4x minus 3. But don't forget that negative sign. So throw the that expression into parentheses and then put the negative sign out in front. And then finish the equation. Equals x plus 3. All right, now we're going to solve for x. The first thing I want to do, though, is I want to distribute this negative sign into the parentheses. So I'll have a negative 4x and then plus 3 is equal to x plus 3. And then now solve for x. So I'll subtract x from both sides. Get negative 5x plus 3 is equal to, remember those cancel out, is equal to 3. Subtract 3 from both sides. Those will cancel. And I will have negative 5x is equal to 3 minus 3 is 0. Divide both sides by negative 5. And I will get x is equal to 0. All right, for figuring out what y is, again, just take what you found for x and plug it into either one of those two equations. We'll go with the top one. So y is equal to 4x minus 3. I'm going to replace x with 0, so 4 times 0 minus 3. 4 times 0 is 0, so I'll have y is equal to 0 minus 3. 0 minus 3 is negative 3. Y is equal to negative 3. And the point where these lines intersect is going to be 0, negative 3. Last one, so we'll go with y equals 2x minus 1 and y equals 1/3 x plus 4. Since both of these equations, or both of these expressions, they're equal to y, I'm just going to set them equal to each other and then solve for x. So we'll do 2x minus 1 is equal to 1/3 x plus 4. And if we did the steps we did before, maybe we would subtract 1/3 x from both sides, but I don't want to deal with fractions. So what I'm going to do is to get rid of this fraction, I'm going to multiply everything by 3. So we're going to do 3 times that, and then 3 times all of that. So when you distribute all of this in, and this isn't going to change anything, right? Because we're multiplying both sides by 3. But if you distribute that 3 in, you'll get 6x minus 3 is equal to 1x plus 12. And I don't even really need to write that 1. We can just leave it as x. So 6x minus 3 is equal to x plus 12. I'll subtract x from both sides. That's going to cancel. We'll have 5x minus 3 is equal to 12. Add 3 to both sides. Those will cancel. We'll have 5x is equal to 15. And then if we divide both sides by 5, those 5's on the left cancel, and we'll get x is equal to 3. Again, to figure out what y is going to be, just plug that value of x into either one of those equations. I'll plug it into the bottom one. I'll go y is equal to 1/3 x plus 4. Instead of x, I'm going to put a 3 there. 1/3 times 3 is 1, so we'll have y is equal to 1 plus 4. And then 1 plus 4 is 5, so y is equal to 5. The point where these two lines intersect, or the solution to this system of linear equations, is going to be 3, 5.